Welcome. This is Mark Schuyler. Today we're going to be looking at one of my favorite geometry slash math concepts. I really like the Triangle Inequality Theorem. You know, it's always stood in the shadow of the Pythagorean theorem, the much more famous Pythagorean theorem, which parents tell me is one of the things they remember best from high school geometry. The Pythagorean theorem, the famous a squared plus b squared equals c squared, that only works on right triangles. This theorem, the Triangle Inequality Theorem, works on all triangles, not just right triangles. It also shows up typically once on every SAT and once on every ACT. So it would behoove us to know it to get one of the harder questions right. It's just simply knowing the theorem. I've presented here an interesting question. Seems really simple. You can't trust the diagram. The note says so, but we have a side of 2, a side of 1, and an unknown base. Well, what could be the length of that unknown side? Could it be 1/2, 1, 2, 3, or 4? Bear in mind, only one answer is correct. The other 4 are impossibilities. So many of my students tell me that they just guess, which of course is better than leaving the question blank, but it's not the right thing to do. We should first make an educated guess. Some of my students have said, well, Mark, there is something called an isosceles right triangle, meaning that 2 sides are the same. So many of my students start to hone in on 2 particular answers. They start looking very carefully at answer choices B and C, because at least that would create a situation where you have an isosceles triangle. But it still leaves the student in a lot of confusion because only one of them's right. Why is the other one wrong? Maybe both of them are wrong. I don't know what I'm doing. So let's take a look and really figure out what's going on here. The theorem says, and I'll show you a slide later on where it's all written out, but right now I just want you to wrap your head around it. The theorem says the missing side, our question mark here, must be smaller than the sum, but bigger than the difference of the other 2 sides. So let's use some inequality symbols to help us out here. Remember, the crocodile wants to eat the bigger number. So our missing side, the question mark, has to be smaller than the sum of the 2 known sides. So it has to be smaller than 3, but bigger than the difference, the subtraction of the 2 known sides. It has to be bigger than 1. It's not this kind of inequality symbol, right? It's not that kind. It's the kind where it literally has to be less than 3, but more than 1. Which means we can take out 4 answers. We eliminate 4 answers. The only answer that falls in that range is actually answer choice C. By the way, I should mention really quickly that many students think that it's best to guess C when you're guessing. Now, it's interesting. I read a study when I was majoring in education in college. I read a study saying that too many teachers, when they make up their own homespun quizzes and their own homespun tests, too many of them do bury the right answer at C in one of their own standardized tests. But this is not one of these, midnight quizzes being whipped out by a tired teacher. This is on either the ACT or the SAT. A lot of thought, a lot of experimental sections and experimental data has been gathered on these questions. So we are not going to see C be more likely the right answer than the other multiple choices, okay? So just wanted to make sure that you understood that, I would have guessed C because that's always the best idea. Maybe on a normal school test it is, but not on one of the big college entrance exams. Hope you found that interesting. Let me show you what's going on with the next slide. Okay, so here we have a whole new situation. As promised, I have written out the definition or the explanation for the triangle inequality theorem, that this missing side down here has to be smaller than the sum but bigger than the difference of the two known sides. Notice the alliteration, missing side, smaller than the sum. I've definitely used all those S's to help me remember the triangle inequality theorem. The alliteration continues with but bigger than the difference. All those hard plosive B sounds, but bigger than the difference. So smaller than the sum, but bigger than the difference. Try to think of it as a little bit of a nursery rhyme. It'll help you remember it. Now, here we have a grid-in, meaning that you don't have multiple choice answers to work with. You have to come up with an acceptable answer for X. The grid-in section was ready to take any answer for X, and if you remember my little trick with the inequality symbols, that's not a bad thing to do. The sum is 12, so it actually has to be smaller than the sum. The difference between 7 and 5 is 2. It has to be bigger than the difference, but bigger than the difference. So if you'd put in any answer, maybe they would have asked for an integer answer, maybe not. But if they were looking for a possible value of X, you just put in one value that fits in that range. Now, sometimes the range is fairly small, sometimes it's pretty large. Let's take a look at the next slide because it's actually escalating, increasing the difficulty to a place where, well, it's about as hard as it gets on the SAT and ACT. And again, not very hard if you just have memorized the theorem. Here is our third and final slide. So here's also where I promised they might say that X is an integer, a whole number, right? So if X is a whole number, our base down here, what is the greatest possible perimeter triangle ABC can have? Well, I'll give you a second to think about that. What numbers go to the right and left of X? Pretty sure you got 25 and 5. But we want it to be the greatest perimeter. The perimeter is the outside of the region all added together. In a triangle's case, we have to add all three sides. We want to maximize it. We want it to be as great as possible. But it would be a terrible mistake to put in the number 25 for this. It can't be 25. It has to be smaller than 25. And you don't want to go down to something like 24.9 because that is not an integer. So you have to go all the way down to 24. Then you just take a second and add together your sides. We know that 10 and 15 is 25. So 24 plus 25 is 49. We have our final answer. This problem, by the way, is considered very hard. It would be one of the last problems on the SAT. Nothing hard about it if you know the triangle inequality theorem. That's why we spent some time on those earlier slides. I wanted to really, drive it home, say it over and over so it would sink in to a place where you wouldn't forget it, even under test day pressure. Enjoyed that? Hope it helps you raise your scores. See you in the next video.